Yeah, you cannot do a presentation about terminals and building terminal applications unless your slides are in the terminal as well. So yeah, welcome to Building Beautiful Terminal Applications. My name is Patrik Svensson. As you can see on the picture, it's me. I'm from Sweden. I'm living here in Stockholm. Father to one, husband to one, non-negotiable apparently. I work as a freelancing programmer currently for a company called Mitigram. And I'm the creator of Spectre.Console, which I will talk a little bit about here today. I'm also a creator of Cake, and I'm a Microsoft MVP and GitHub Star. So the next slide is super important, actually, and it's I got you. So before I start the presentation, I know that there are different meanings of some terminology depending on how long you've been working, where you were born, and stuff like that. So I was thinking that maybe we should go through some terminology. So when I say console, originally, back before I was born, that was an actual physical device, a screen or a printer and a keyboard. But nowadays, it's synonymous with terminal. So nowadays we use it pretty much interchangeable. And a terminal was the original meant a teletypewriter or TTY. And it was actually a device hooked up to a printer, the typewriter that outputted the whatever the content of the terminal. But nowadays we use it to talk about the software that displays the text output in some way. So iTerm on Mac or Windows Terminal or stuff like that. And terminal applications are applications that run in the terminal somehow. And the shell, that's something that runs on top of the terminal, executing commands. So it might be Bash or PowerShell or CMD or whatever you use. When I say CLI or command line interface application, I mean an application that accepts text input from the command line or standard input and executes it. So an example would be like Git, which is executable. And here we send some text to it. And the shell normally splits it up into tokens. So normally you will get like a array of pointed to char or in C# a string array or something like that. So what is Spectre.Console? And Spectre.Console is the library I'm going to talk about today. It's a .NET library that makes it easy to create beautiful console applications. It's as easy as that. It targets .NET 7, .NET 6, and .NET Standard 2.0. And it's very much inspired by a library called Rich for Python, which I was using a lot, and I really missed that in .NET. So I started porting over some parts, and yeah, that's good to know, because if you know Rich, you probably understand how to use Spectre.Console. And another important question is, what is it not? Because we're getting a lot of issues and questions about people wondering how to use it, and it's not a terminal UI library. So we don't support like mouse support or clickable buttons or hooking up some event handler to something. It's just for rendering pretty stuff in the terminal, more or less. Oh yeah, so we have no redrawing of like widgets or buttons or anything like that. or tracking state. You have to do everything like that yourself. Yeah, the problems it does solve is, like I said before, it's displaying different kind of static read-only stuff on the screen, like text or layouts and trees and stuff like that, but not interactively. And it also makes it easy to parse the arguments that are passed to your application. And the problems it does solve, it hides a lot of complexity. And now you might wonder, what complexity? It's just a terminal app. But there's so much history and baggage and things related to terminals that a lot of stuff that you don't have to do yourself, such as everything in Spectre.Console generates VT codes, VT100 codes. And VT is, stands for video terminal, and it was machines, actually. So they had this instruction set of things to write, an instruction set. So it's like a mix between something like HTML and OpenGL, because it's completely stateful. So if you wanted to turn the text red, for example, you would actually write a command sequence to the output stream, and everything would be red until you reset that state. And later on, they actually standardized the VT100 instruction set in ECMA 48. So you can say ANSI code sequences or VT code sequences. So if you see something like a VT100, that's an actual old machine that ran a specific instruction set. We do a lot of detection of terminal capabilities. So, for example, does this terminal even support VT sequences, code sequences? And you might wonder, what? Of course, no. Like cmd.exe on Windows, it did not support this until Windows 10. So if you want to run it on an old Windows server or something like that, we need to be aware of what it supports. And we also support different, how can I say it, different parts of some terminals support more capabilities than others. So we actually detect what capabilities a terminal that you're running your application in, what it supports. We also know what color system that's been used. So 8-bit or 24-bit or 3-bit colors. We're using some heuristics to know that, but it works pretty well. Are we even writing to terminal? Maybe we redirected our input to a file, for example. Then we don't want to emit these VT codes. We just want to output the text. Does we support Unicode? That's on Windows. You will often, maybe you've seen these question marks instead of a nice emoji. That's because Unicode code isn't supported in that terminal. And it also, the output encoding of the standard out needs to be Unicode enabled as well. And this one is a fun thing. How many cells does a character occupy? In Western languages, normally there's a 1-to-1 ratio between characters and cells, and a cell is like, this is a cell, if you can see on the screen there, the array. But if you're gonna render Asian characters or emojis, you might find out that even though it looks like it's one character, it's actually take up 2 cells. So we want to know how many cells each character occupies, just to know how to format stuff and render stuff. Like if you're rendering a table, you don't want the table to be skewed just because someone put an emoji in it. We want to be able to calculate that correctly. And we want to know, of course, if the current terminal is suitable to display more complex things. Like if we do live updates, that often involves like moving the cursor using VT codes. Looks really good on a terminal when you run something locally. Does not look that good in GitHub Actions when you look at the log. Same with progress bar. Maybe you've seen this. I don't know some JavaScript build tool that outputted like 1,000 progress bar in the build output. We want to know that, so instead of showing the progress bar, maybe we just write the current state or something like that, like updating foo 50%. And it supports no color. So if the user opts out of having colors in the terminal, we will respect that. But we will support 3, 4, 8, and 24-bit colors if the terminal is capable of that. And we also do auto conversion. So if you specify a 24-bit color RGB, and we detect that the user is on a 4-bit, we will actually do auto conversion and fall back on the closest color, according to the Xterm 256 table. So it will still look. Of course, it won't be as pretty as this, but it will look. You will be able to see it. Yeah, that's red. That's green. It looks okay. You can, if the terminal supports it, you can do different styling of text, like I showed before. And for this, we use BBS markup language that reminds a bit of HTML. So the code you see up here is actually written like this when you output text in Specter.Console. And of course, you can specify colors in the same way, either the Xterm 256 name or an RGB color or the hex. And you can even set like background color by using the on keyword. So black on red, for example. And you can, something that's really nice is that you can justify the text and it will automatically word wrap. So instead of breaking off a word in the middle of a sentence, it will actually word wrap it correctly and you can align it on the screen as well. We support tables. So if you have some tabular data, you can display that in the terminal. And everything in Spectre.Console is implemented using something called iRenderable, which is an interface. And tables supports nesting of iRenderable, so you can have a table in a table in a table, for example. So here's a table, and we can stretch it out. We can align certain columns. We can give them colors. We can align them. We can change the borders. Like markup tables are pretty useful if you like outputting text to the terminal that you want to, where you want the user to quickly be able to paste it into a GitHub issue or something like that. It's really useful, I think, personally. Yeah. So, and you can create your own borders as well if you want that. And if you want to represent some hierarchical, can't pronounce that word, data, like a tree. You can do that using we have support for trees as well. So on a regular tree, we can style it using this markup language. We can collapse nodes. We can insert other iRenderables, such as a table or whatever you want, or a graph of some kind. And you can change the line guides as well, or implement your own line guides. That's pretty cool. It's been super useful to me, at least. Hopefully for you as well, if you decide to try it out. So what else can it do? It can do a lot of stuff, and I don't really have time, especially since I'm a bit late. I won't have time to show everything, but there is a great documentation, not created by me. That's why it's great. On the site, where you can see other stuff in action. Um, oh yeah, and we also have support for layouts. So if you want to arrange stuff, irenderables in different layouts, you can do that. Like you can split them, for example. And like this application here is, I'm just using layouts for that. The presentation tool. Yeah. Any questions so far? I'm talking way faster than I do when I'm at home alone practicing. So right now I'm using Windows Terminal. No, sorry. I'm running. It's Windows Terminal with PowerShell. So, but I can show you. Mm, source, GitHub. Sveatug. Slides. Oh yeah, it's a sorry. It's a PowerShell script, so that, and it's called dir. What's it called? Specter presentation. Let's do a .NET run here and see if it. So here you can see an example. I didn't use the emoji functionality, but next to my name, which I should in retrospect. So you see this the famous. Yeah, and another thing, since this cmd.exe doesn't support Unicode, it does support if you can change it, but I haven't done that. So instead of rounded borders, because that's the Unicode characters, it actually falls back when it's rendering this to using the ASCII table, ASCII characters. And I'm not even sure. Oh yeah, it works. Yeah, and I should have used the emoji functionality, but I was lazy. So as a, oh no, not yet. Let's do it like this. I was thinking about doing a quick demo where we implement a small application. Shouldn't be that much code, but it will give you a good understanding of how you can use it. And sorry. Forgot you saw anything of this. So for this demo, I created a small client that will connect to an external service and get some trivia questions. And for this demo, I was thinking that we should write a simple terminal client to play a game. Yep. So we can just to test everything out, we can let's see if it works. No. So let's start with, for example, we want to display a nice logo for our trivia client. So we access the ANSI console, which is the static singleton, but it's actually built around unit testing, so you don't have to use the static stuff. You can access the not render. It's called the console. And this we have a test framework if you want to write unit tests for terminal output. But we can just do we want to write to the answer console, and we want to write some big figlet text, and we want that text to be yellow, for example. So you have something like that, and you can load other figlet fonts as well. So now we want to use the client to actually get the categories. So we could do like this, categories, and we await that one. And we would get a list of trivia category back. But let's use the online one instead, trivia. I'm not trusting my the demo ghost, so I actually created a offline version as well. So if we run this now, it's going to show the logotype, and it's going to fail because I have forgot a semicolon or something. Oh, did I just forget to save? Yeah, and that's not very nice. You know, we're not showing the user any output or what's happening and stuff like that. So let's fix that by implementing a status. So we have something called status, which maybe I should turn off the sound, which we can start, and we get an initial status like we're getting categories. And it takes a lambda. And let's just move this up here, like that. And make that async. And now we need to await it. And let's assign the categories. So now if we run this, we'll actually get a nicer, hopefully. And it was so fast that look away. Like that. No? Did I use the wrong version of this? You know what? I think it's called start async. So now we're getting this nice progress bar, and it will be removed once we fetched all the data. So now we have all the categories. We could just enter a prompt and let the user write the category, but wouldn't it be much nicer if we let the user select from a menu or something like that? So we have this thing called not await, ANSI console selection prompt. Sorry. It's a wonderful opportunity to show you the documentation because selection prompt there. Oh yeah, sorry. So we're gonna have a prompt, and it's gonna be a selection prompt that takes a list of trivia category. So trivia categories are item type, and we're gonna add some choices, which are gonna be our categories. And we're gonna assign the result back as a choice. So if we run this again, and get the categories, and of course that's not gonna work because it doesn't know how to display it. So we need to tell it how to. We need to use a converter, and it takes a use converter, takes the category in, and we want to have the name for the category. So if we run this again, we will have a nice list of categories. So now when we have a category, we want to actually start a game. So let's start and fetch a question. Client dot get question. Yeah, and this is a asynchronous operation. So my little framework actually. Let's copy the call that getting question. Let's remove that. And client.getQuestion. It wants the context and a trivia difficulty. So let's just say that it's we want hard questions. And we provided the category. No? Choice, of course. And now we want to display the question. And maybe it would be nice with using a similar list as we did before. So let's just show let's call that one selection. And we're going to add the question dot choices. I really wish I didn't use the choice. You call it category. And it's not a trivia category, it's a trivia, it's a string. So we don't need to do anything. Use selection prompt. It can't infer the type anymore. So now we should show a question, and it should continue in. And then we just check if the selection, which is a string, equals the question.answer, then we can just display some markup. Yay! like that. Otherwise, we shouldn't encourage that. So let's. So. Say what? That's a very good thing to do. So, good catch. I was just checking if you were awake. Let's set the title to the actual question. So, question. Don't design your APIs like this. So let's try. Let's try to run it again. Getting categories, and what category should we choose? Video games. Okay, sure. In Sonic the Hedgehog 2 for the Sega Genesis, what do you input in the sound test? What is this nerd question? Anyone know? It must be the lead programmer's birthday. I would have added that. Yay! Which Souls game was not direct? Okay. Let's just use them. So yeah, it kind of works. So let's go back. Yeah, we can. I don't think I have that much time left, so I could just show you some other stuff. That's always nice to. So we use this .NET example application. No, it was not. Did I write list? .NET example list. Select. Thank you. No. So there's a lot of different examples, but some things that are useful that I thought I would is the progress example. So if you're downloading things from the internet or connecting to some, I don't know, processing something, you can use the progress bar. In this case, we use the Star Trek we're starting a engine and writing some random stuff to the log. There are you can do some live updates in the terminal, but it's very restricted. But for example, if you want to show some, like in this case, we want to show some exchange rates, which are totally made up. So don't go buy currency after this. And this table was too big to display because it continues. So it will actually truncate it, and you can select how to truncate it if you want to. Yeah. No, not much interactivity in this one because it's mostly Spectre.Console. I only use it for like read-only stuff and views of different kinds and stuff like this maybe. But I mean, I wrote a presentation tool with it, so I guess you can. Yeah. And we have can't remember what this example was, but now I got curious. Yeah, this is just a minimal example. So, and we got stuff like JSON support, for example. So if you want to render JSON nicely to the terminal, we will actually do the tokenization and outputting it. And you can select what colors to use and stuff like that. There is literally so many examples. And if you want to run them yourself, you just clone the repository and then you write .NET tool restore and then .NET example, and you will get a list of all the available examples. So with that, how do I switch tab? Thank you for coming. Any questions? No, almost, but we haven't put any work into it. But we will do that because yeah, yeah, absolutely. We started with this .NET 5, and it was really not as great as it is now. But we will add some. We will try to add it once I learned how it works. So maybe not. No. Yes. Yeah, sure. If I find, I think it's the canvas example. So here it rendered some, and we have integration with image sharp, so you can actually manipulate the images before rendering them to the terminal. But we're going to add support for pixels. So you're going to get even nicer images, but it's not that supported in all terminals yet, so it might take a while. Yep. No. Yeah. 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 Yeah, sure. Why not? We have 6 minutes. No? 10 minutes? 10. Okay. So you might think that I was unrehearsed before. I actually was. Now I'm going to do something I haven't really thought about. So let's see how this goes. Yeah, so how it works is that there's a lot of great command line parsers for .NET. So what we're doing in Specter.Console.CLI is just a very opinionated approach to parsing. And I'm just going to add a reference to it if I find the edit project file. So we're just going to add there. Oh, running an old preview version as well. That's great. So what we do, we wanted to enable composition of commands instead of this. So what we do is that you create a command. So my command, like that. You add a reference to the, you import the namespace Spectre.Console.CLI. You say that I want to have a command of my command.settings and create a settings class down here, which we inherit from command settings. And we implement this method. We use the ANSI console and just write something. And in our main method, we create a command app. And we configure it. And here's the different part from most other. We say that we want to add a command at the root called my command. And we call that, let's call it foo. And we want to take some options as well. So let's add a property called name. We want to make that optional. So let's use a command option. And we say that you can either enter it as a -n, no, there, -n or --name. And it takes a so here when we receive our settings, we can just do we're good coders. Let's make that. So if settings.name exists, then we write out hello name. Otherwise, really rude not to introduce yourself, so like that. So if we run this now, if I can remember where I put the just run it. Did find. Oh, you know what? Something that's really good to do when you write an application is actually running the application. So let's run it with the provided args, like that. So now it just say, hopefully, oh no, it would show the help screen because we didn't provide a default command. So let's just write .NET run foo, and it should run the root. So let's add name. No value provided. What was that? Patrik. Yeah. So the benefit of this approach is that it's really easy to combine commands. You can even add branches that you limit on the settings type. So for example, you want to learn if you have a settings type, you can add a bar command, and you can configure this to be so it's really easy to experiment and move stuff around, and it's not I mean, system command line is awesome library, I think, but it is a lot of codes, and you have to be really specific about how you define your commands and stuff like that. So this is a more lightweight approach to it. Yeah, absolutely. Got 4 minutes left. Anyone got any questions? The Rickroll video? Yeah, of course. No, slides. There, I like it as well. Yeah. So this, I mean, we have 3 more minutes. Yeah, I think so. It was a while I wrote this presentation. Rickroll slide. Yeah, it's really inefficient as well. It loads the GIF, and then it just has a counter, frame counter. And then we create this pixels object with a image sharp frame, and then we just we align it in the center of the image, and vertical alignment in the middle. And then we just spit out a new layout that consists of two parts, one with the image and the lower part with a joke. Yeah, so that's it. Not fancy. Yeah, I'm not gonna keep you hostage anymore. So thank you.